So hey everyone, welcome back to my channel. This is Lakshay here. So today we're gonna start with the lead code question number 39, which says combinational sum. So it's a medium level question. So let's see what it says. It says given an array of distinct integers candidates and a target integer target. Return a list of all unique combinations of candidates where the chosen numbers sum to target. You may return the combination in any order. The same number may be chosen from candidates and in an unlimited number of times. इसका मतलब क्या है? Means how it what it means. It means that any number can be repeated any number of times. Means here is only one time is two. That doesn't mean that a subset with will only contain one two. It can contain any number of twos. Okay, so that's what it's saying. So we have to make such combinations that the sum of our combinations will result to our target. Okay, so let's see in the example like here. So here we can see what we have given. We are given a array of like these numbers, and we have to create our target as 7. So what are subsets? So we know that if we add 2 two times and it one times, then we get 2 plus 3, which results in 7. So it is equal to our target, so it can be a subset. Another we can get is a 7 itself. It is also subset, and nothing else. We can't create any more subsets. Similarly, let's suppose we have like this a string array, sorry, and a target equals to 8. So what can be our subsets? A subset can be like this. This can be a subset because there is in the question that we can repeat the number any number of times. That's why we have repeated here 2 4 times. So it can be a set. Then another is 3 5. This can also be a set, and many other more maybe. So how we can find these sets? Let's see. So let's take the first example only. So it says that our target equals to 7, and we have number a number as or array as 2 3 6 7. So how we can approach this? Let's say at beginning we have nothing. Okay. So first of all, let's suppose our I is here. So we can traverse for I like this 2, and we can now subtract it with our this. So we are now having 5. Okay, now we can see that what we can take. Now we are again having 4 options. We can take anything. Now we are again taking 2. Now we are having 2 2. So we again minus it from 2. So we are having now 3. Now we again take 2. So now we are having 3 minus 2 equals to 3 minus 2 equals to 1. Okay, like this. So now we again took 2. So now we see 1 minus 2 equals to minus 1. So we can see that it is not becoming 0. It is now going to negative. That means we can't proceed further from here. So we will simply return from here. So now what we are having here from other options also. Here we took 2, but we can also took 3. So if we took 3 like this 2 2 2 3, we will again don't get our answer. It will definitely increase our value. So we will again return. And similarly for the 5, what were the cases? Sorry, it's 6. So similarly for 6 and for 7 also we don't get any result. So what we will do, if we will simply return from here, then we moves here. Okay, so we have tried for 2, then we will try for 3. So it will be like this 2 2 3. So it becomes now equal to 0 when we subtract it, because we have already subtract 7 minus 2, then we got 5, then we again minus 2, then we got 3. Now we again minus it with 3, so we now get 0. That means it is a valid string, sorry, a valid subset. So we must push it into a resultant set. Okay, so that's why we pushed it, and then we again came back. Okay, now we checked for 5 also, sorry 6. We can see that it will exceed. Then we again checked for 7. We can see that it will again exceed. Then we again recurse back, and we have checked here for 2. Then we check from here 3, like this 2 3. We can see that it is can still hold more values, so we will add again 3 more. You can see 3, 4, 5, 6, 7, 8, 9. It exceeds, so that's why we will simply return back from here. So now we are again here, so we can see that it can again have more parts like 2 3s. So we have used 3, so we can now use 3 6 also. So 2 3 6, it will also exceed. At last we will get this string only. So when we done all the recursion here, then it returns like this. And now we will perform for 3. And similarly it will also create subsets, and also may try to find, but it will not find anything. Then it will again try for 5, then it will again try for 7. And we can see that 7 is also substring, so it will again add it to our resultant and it will return back. Okay, so this is how all this recursion will work out. Okay, so let's first write down the pseudocode, then it will help you understand more clearly. So let's down a pseudocode here. This will be our main function. Okay, so first of all, what we will create a resultant vector. Okay, that will create a that will collect our answer, and it will, and a combinational vector that will, that we are going to come, because we are creating combinations different. That's why we will store that combination here, and all the combination in the result. Okay, now let's call a function. Let's suppose our function is backtrack. So what will we will passing our nums array and a target. What else? At index, that will be starting at 0. We will start from our first element, and obviously our combination and resultant array. And at last what we will return, we will simply return our result. Now let's write our backtrack code. So the same we have wrote here, we will pass here. 0 will be called here as index. Okay, okay, so first of all we will check if our target is equals to 0. That means our subset is complete. We can directly push it to our result. That's why we will push it result dot push back our combination, and we will return from here. Now what will be our next condition? If our target is in negative, that means it's smaller than 0. That means the values of the combination set are getting larger by larger. That means it can't be our answer, so that's why we will simply return from here also. Now if that's not the case, that means a target sorry, then it means our target is still having some values remaining, so we must pass some more values, push some more values to our subset, to so that we get our target equals to 0. So for that, what we will do, we will start a traversal for I equals to index till I reaches I nums dot size, and we will I plus plus, so that we can try all the combinations. So what we will do, a combination dot pushback a nums of I. Okay, and then we will check that if this is suitable for us or subset or not. So for that we will call backtrack, sorry. And what we will pass, we will pass the same, our nums, our target, but we have to minus it from our nums of I. We have to minus that number, and our index, that will be in I, and our obviously combination set, and our result. After that it will return our answer like we did earlier, na? Like this. We called for 2, it will return. Then we have to add 3. We have to try this combination also. So to try this, we must pop this one first. So that's why we will pop combination dot pop back. Okay, like this. Like this, we will keep on checking on all the combinations, and we will also keep on checking here also, that if our target reaches 0, then we will simply add it to our back to our result vector, and it will simply return. Okay, so that's our pseudocode. It's simple. This is how we are going to approach this problem. So below down I will paste the original LeetCode code, which but before that you must try on this, and we should practice the dry run as much as possible. So let's see the code here. As we discussed, it's same. We have first created a vector result, then we created a vector combination, then we called our backtrack function. Then what we did, here is a backtrack function, same. Then first we checked if our target is 0, that means we have reached our combination, we got our combination, so we push it back to our resultant vector. If our target is smaller than 0, that means we have values that whose sum is greater than our target. That's why we'll simply return from here. And if that's not the case, then we will add on all the combination, like we are having 2, then we're again adding 2 or 3. We are trying different combination with the help of these loop. We're adding one element and then we are calling a backtrack to check if that element is suitable and can we add more element like this. That's why we are calling this function. Okay, and then while backtracking we are popping that element, and at last we are returning our resultant. So that's it, a pretty simple question. I guess you can understand it more clearly the more you try different examples. Okay, so now let's discuss the time complexity. So the time complexity is for this code is like, you can say big of n, but but it's not exactly big of n, it is big of n to the power t upon minimum combinations, like this. So I can't explain it too much, but you can check it on any site or with the help of ChatGPT. It will explain you in much detail. But I can tell you that in here, this T represents our target, and this minimum combinations is our combinations only. And the space complexity, sorry, and the space complexity is, let's create first, and the space complexity is big O of T. Okay, that is our target that we are trying to get by recursively calling our function again and again and subtracting the nums. So that's it. This is your pseudocode and your code. So that's it. See you in the next video. Till then, stay updated. Thank you. Bye bye.